Yo, it's the battle of the titans, tech giants colliding. Sora from benign, crushes Kling ain't hiding. Sora's got the vision, precision like a surgeon. Kling's got the speed, feeding needs, it's emerging. Open Sora next level creation. Sora's got the data, backed by innovation. Model so tight, it's a digital sensation. From deep learning stacks to the art of the frame. Sora's in the game and it's changing the name. Why should Kling revolutionizing the scene? Kling's on the rise, quick with the surprise. Algorithm King's got that AI prize. From China to the globe, they ain't taking it slow. Kling's got the flow, making video glow. It's Sora vs Kling, who's gonna win the ring? AI showdown, let the tech head sing. Sora with the depth, Kling with the speed. Who's gonna lead in this AI breed?
Kling obviously was one of the hottest topics past week. But today what I want to talk about is AI generated music. So everything you just heard is 100% AI generated. The last time I really tried the music gen was around 8 months ago, but back then it was really difficult. I can either just find text-to-speech model that it only speak but don't have any rhythm, emotion, or everything that is needed for completing music. Or I can only find a model that is capable to generate instrumental music without vocal. And after that, I just never touched music generation again because I thought it was just way too far from actual production usage. Only until last week, I was reading a paper called Pops, which is a quite interesting paper around image generation. But what really caught my eyes was a project introduction video, which is not like any type of demo video you saw from those AI research paper, but a video comes with a song.
The clipped image embedding space is semantically meaningful, yet the specific meaning can vary unpredictably. We introduce pops, a framework that trains semantic operators directly on clip image embed.
You got the idea, and I thought there's no way an AI researcher got to write a song about her projects. Then I realized this audio track is actually generated by an AI music platform. So I give it a few latest platform a try like Suno and Udio, and the results from both platforms are really impressive. And that's time where I realized things on music generation really came a long way past few months. And this got me interested in learning a few things about music gen, which is how does music generation actually works and where we are with this technology right now. So for the past week, I did a bunch of research and also tried to build a demo myself, which is a simple application where users can just upload any video and we can turn this video into an MV with a personalized song. So today I'm going to share my learnings as well as a step-by-step of how can you build a music generation related application. But before we jump into that, I know many of you are building interesting AI products. And often the easiest and best way to validate your product idea is spin up a website to showcase the world and see if you get any early attractions. That's why I want to introduce you guys to Hostinger, which is my preferred website builder. With them, you can make a website with under $3 per month. And for most of the people who are watching this that are interested in using AI to automate the process, Business Plan is a great choice because it enables you to create up to 100 websites, more than 100,000 monthly visits, as well as a ton of useful AI features that I'm going to show you. So I'm going to click on this choose plan. Then we are going to choose a period. I recommend doing at least 12 months so that you can lock in the lowest price. And before you check out, making sure you type in the coupon code AIJASON, which will give you additional 10% off. You can start building your website with AI. Just provide a name, AIJASON Music Studio. And you can choose different type of website with backend already built in, like online store, blogs. But for this specific one, I want to choose portfolio. Just provide a paragraph of your project. You can even customize further with different style and colors. And just click on create once you finish. And then the AI will just take care of the rest. Within a few seconds, a beautiful website is already created for you based on your requirements. You can customize everything really easily. You can activate AI writer on every single paragraph, putting a drop description you have, and then it will generate SEO-friendly copy, ensuring your site ranks high on the search engine. They even have a feature called AI heat map. They can predict your visitor behavior, so you know exactly how to optimize your site for maximum engagement. So if you're planning to build any website recently, I definitely recommend you go and have a try. You can click on the special link in the description below to sign up and get 10% off on your Hostinger account. Now, let's get back to AI generated music. So how does music generation model actually works? At high level, the music generation model is pretty similar to the image generation model, which are all using the diffusion model. And if you don't know how diffusion works, diffusion is basically a process of remove and add noise. The way image generation model works is that it will start with a very noisy image, but the model is trained to be able to remove a little bit of noise every time until it gets to a high resolution image. Same thing for the audio diffusion. It will basically start from a very noise audio clip, and then it will try to reduce the noise a little bit every time until it gets to a very high fidelity audio clips. So those are basically the methods of how the music generation works. And the most challenging part is actually joint embedding. So joint embedding basically means that it needs to be able to understand the relationship between the prompt, which can be the text, or it can be even other audio clip and even image, to the final audio data. So if you imagine that as a real music artist, it needs to do two things. First, when someone said love song, it needs to understand what does that love song means, what type of songs are similar to this type of request, so that it can create new stuff that is similar in this category. And to illustrate this, all those multimodal model like GPT-4V or Google Gemini are going through a similar process, but try to create joint embedding between the text, image, and audio. And behind the scenes, they basically just tokenize all those different type of data and figure out a way to create this joint embedding. The difference here is that the music data is extremely complex. There are a huge amount of data points that we just subconsciously consume, but didn't really quantify, like rhythm, melody, frequency, emotion, amplitude. And each one of those things are really difficult to describe with text. And without comprehensive description of a music, the same text prompt can lead to wildly different results. But on the other side, you can also argue it is the same challenge for the image generation as well. There could be absolutely a gap between the text prompt or text description to the actual image. It is definitely true, but there are two parts that make music generation a lot harder than image generation. One is that it is still proven a lot easier to describe image rather than describe music. The second part is that the amount of available high quality data for training image and text are multiple levels higher than audio data. And without this data, it's very difficult to train the model. So the question now is, with those conditions, how can we still effectively train a text music joint embedding? So there are a few public examples that we can look into. One example is Google's Music LM, which is something they published last year. They basically have 3 different models to generate 3 different types of embed tokens. One model is called Mulan, which is an audio language model that can take in both audio or text, and can generate a sequence of 12 audio text tokens per second, designed to represent both music and corresponding text description. And on the other side, there's a second model called W2V-BERT, which is a special model that generates 25 semantic tokens per second that represent a feature of large-scale compositions, such as consistency in timbres or motifs, so that it can generate tokens that represent long-term coherence. And in the end, it has a third model called Soundstream that is designed to generate 600 acoustic tokens per second that capture the fine-grained acoustic details that allows the model to output high-resolution audio. So with these 3 different models generating 3 types of different tokens, we can capture a lot more details of each audio clip. So during the training stage, it was able to just provide target audio clips and then generate the joint text and audio embedding with these different models. During the inference stage, when the user give a text prompt like hip hop song with violin solo, the Mulan, which is audio language model, will generate textual token first, as well as predict the semantic token using the semantic modeling, and in the end, get all the acoustic token that capture the details of the music and use all those data points to actually generate audio that is cohesive. And this is just one example of how Google overcame those challenges in music generation. And I'm sure there are new methodologies also show up recently. The next question is, where we are with this technology now? Is it actually ready for some commercial level application to be built on top? And the easiest way to figure this out is try it yourself. So the 2 most popular platforms now, one is called Suno, another is called Udio. The one I tried more is Suno. So you can basically just come here and then put in a song description and click on create. So here I give it a try and generate a song description like a rap song about a girl called Shirley Lu who was passionate about trading stock, keep practicing after 5 years, making no money, and eventually win the UX stock championship. So this is like a super niche song that absolutely won't exist before. And after I click create, it generates 2 song examples. And the result is actually pretty good.
Let me tell you a tale about a girl named Shirley Lu, passionate about stock. She knew just what to do. She studied the market day and night, no time to lose. But after 5 long years, she still couldn't crew. But Shirley Lu, she didn't give up.
So the result is pretty impressive, right? And if you look into the actual lyrics, you will see there are some kind of special tags like the verse, bridge, and chorus. And those are some of the prompt tactic for Sono music generation, which they refer to as meta text. Basically, you can add additional prompt or meta text into the lyrics to steer the direction of music better. And those meta tags are normally pretty short, no more than 3 words. Like common ones are verse, intro, chorus, but you can also add a bit more details for each meta tag. Like for verse, you can add a sad verse or rapped verse or exciting happy verse. Same for all the other tags as well. And there are a lot more other tags that is commonly used by people that seem to be working well. I list some of them here, but there's a video from AI Controversy, which is pretty good, talk about all the secret prompting tactics. So you can check that out as well if you want. But with all those advanced prompting tactics is when you go to custom mode on those audio generation platform. So if you turn that on, that will give you additional field. One is the lyrics. And this is where you all the detailed lyrics with those meta tag and special text description of the audio. You can also choose the style of the music as well as title. This is basically how I generate the music of Sora vs Kling at the beginning, where I actually use some of the tactics like verse as well as ad-libs into the lyrics and give a tag like 90s rap as well as title. And the result is pretty good.
Yo, it's the battle of the titans, tech giants colliding. Sora from benign, crushes Kling ain't hiding.
So this is an example of how you can use those existing model and platform to generate music. But as AI builder, I definitely want to use this model or API directly so that I can build an application on top of it. Unfortunately, there's no official API from Sono. However, I do find an open source project on GitHub. Someone basically just hacked their way around and provide an unofficial Sono AI API that you can use in Python. All you need to do is just open the network tab, and there will be some network request token Clark JS version equal to something. And you just need to copy session ID as well as a cookie so that you can use your own account to get API response back. But on the other side, they also just offer the API at 50% lower price. And I tested it and actually works. So it depends on your needs. You can just use your own account or use this Fox API as well. So based on this, I want to build a quick demo application where it's basically a music generator that can take either a video or a PDF file of research paper or comic book, then generate a corresponding music that go along with this media file. And to build such application, I decided to use Gemini because it is probably the only model available online that provides real multimodal understanding ability. So I can just chunk in a whole video file and it will be able to understand. And from there, the model should generate a song prompt, which can include the lyrics, the song style text, as well as title of song. And in the end, send those prompts to the Sono API to generate a music that can go along with those videos to generate MV. And this is actually extremely easy to build. I'm going to show you how can you build it in just 5 minutes. So firstly, let's open Visual Studio Code, which is where we're going to develop this project. And I'll create a new file called file processing, py. So this is where I'm going to create the function that we're going to use to read the video or PDF file to generate the music generation prompt. And firstly, we will import a few different libraries that we're going to use, including Google Generative AI, which is the one that can call the Gemini model, as well as a package called Instructor. So Instructor is quite a popular package for forcing a large language model to generate JSON output. Because even though Gemini or OpenAI do support JSON mode, sometimes it still doesn't really generate JSON output. And this package is really useful for that. And to get your Google Gemini API key, you can go to aistudio.google.com and then just go get your own API key and put in here. And here I'm going to create a new function first called upload a video file. So this will take a video file on my local computer and then upload to Google so that it can be passed to Gemini. And then I'll create a second function called chat video Gemini. So this will taking the video file as well as a prompt, and this prompt will be optional. So I will firstly upload the video file to Google first, and then I will define a pandemic class. So this is how you're going to use Instructor. Instructor allows you to define specific data structure. So in this case, I will create a model called music prompt. Inside this music prompt, I wanted a few different information. One is the video description, including the storyline, key elements, and transcription. And then I wanted to generate music title based on this description, as well as music style tags, which can be an array. And in the end, I wanted to generate music lyric. So with this defined data model, I can create an Instructor client. So it is basically wrapped around the original Gemini model. And then I can just call this Gemini model, use instructor by doing instructor client message.create. And the message will be, firstly is a prompt. Your goal is to generate a proposal of music that goes well with the video. Specific requirement you have to follow will be the optional prompt that the user might give. And then I will add a new message for uploading the video file. And the response model equal to music prompt, which is the data model that we defined above. So what this will do is that Gemini will try to generate response based on this data model that we provided. And instructor is basically a library that will help us to do the validation and retry if the Gemini model failed to generate response in that specific format. In the end, it returned the result. So this is pretty much all we need to use Gemini model to generate the music generation prompt. And next, we want to create new functions to generate music. And I'll create a new file called generatemusic.py. And firstly, let's import a few different libraries that we're going to use and define the endpoint that we're going to call as well as headers. So you can get all the detailed API examples from sonoAPI.com. But basically the one we're going to use is firstly create music task. And this will basically call the API endpoint to create the music with the Suno API. But this API will only return the task that it created. Because music generation tasks actually take quite a long time, we will need to create another function called query result to actually check if the music generation task is finished. If it is not finished, then retry again until it has been finished. Then we can return the actual music URL. And in the end, I'm going to create a new function to combine everything together called generate music. It will take the title, text, prompt, and model, which have default value. And this will create a task on Sona first, then get a list of task ID. And we're going to continue check if the task finished. If all the music generation task status is either complete or arrow, then finish and exit this loop. Otherwise, it will continue check every 1 second. And in the end, it returns the finished audio URLs. And that's pretty much it for both generate music as well as generate the music generation prompt from Gemini. And in the end, I want to create another helper function for remix audio and video together, because in the end, I want to generate a kind of small MV with the new audio overlapped on the original video. So in here, I will create a new file called remix audio video.py, import a few different libraries. We will have one function to download the audio file from the audio URL that returned from Suno API. And in the end, create a function called overlay audio. So this will load the original video file, get the original video resolution with the CV2 library, and then load the new audio file and get the original audio, but set the original audio to be volume 1%. You can increase this a little bit if you want. And also trim the new audio as well. So if the Sono generated music is longer than the video, we'll just trim it to be the same length. And then we're going to combine the old audio and new audio together and set it as new audio and save the new video file. So that's pretty much it. All we need to do now is we can create a simple UI to combine everything together. So I'll create a main.py, include all the libraries we're going to use. And first, let's create one function called generate music video from a video path as well as special prompt. And this function will basically generate the prompt first, and then get Sono generate music and get music URL back. Then download the newly generated music and then add that audio to the original video. And with this function, I'm going to create a Streamlit UI quickly. So I will have a UI for user to upload a video file. So I will do st file uploader. And then if there are any file uploaded, I will get the file, save the file to a temporary location, display the video that the user uploaded, and have a place for a user to type in the special prompt that they want to pass on, as well as button to generate music video. And after they click on that, we'll basically trigger the pipeline that we created earlier and save and display the video once it's finished. And this is pretty much all we need. All we need to do now is just create two new folders. One is the temp file folder. Another is the new videos folder to save the newly generated videos. And we can open terminal and do streamlit main.py. Okay, great. So I have this UI ready. Let me try to upload a video file. So I have a video file which I shoot on a little camping vacation with my wife earlier. So I can just upload this file and then add a little prompt called a wood camping weekend with my wife and click on generate music video. If I go back to the terminal, you can see that the file has been uploaded and it is uploading to Google, and then it gets the video generation back from Gemini. So a man is recording a woman through the window of their wood camping. It is raining outside. The woman is sitting on the bed smiling and waving to the camera. When the man says that the window reflection makes him look short, the woman starts laughing. He then enters camping, which is exactly what happened in the video. And you can see what's amazing about Gemini model is that it will understand the video itself and also understand audio inside the video. because it actually understood what I said in the audio, which provides a huge amount of additional context that GPT-4 model won't be able to do. And then it generated a music title, Camping Laughter, with some of the text as well as music lyrics. Raindrops on the window pane, cozy camping in the rain, smiling face, a gentle wave, laughter echoes through the day. So it's pretty good and reflective of what is in the video. Okay, so the music generation just finished and it returned true audio file here. And if I open a newly generated video, we can see the result.
Raindrops on the window pane, laughter in the air, wooden walls and cozy light, a moment we can share, reflections in.
The result, I reckon, is actually pretty good. I love the vibe of music and it is exactly in sync what is inside the video. And I can totally see people generate vlog with personalized music. And I've put the link of this Streamlit app in the description below so you can try it out yourself. And I'm actually pretty keen to build a kind of a little consumer app where people can just shoot a video and generate a good MV with personalized music. If you're interested, please let me know. You can sign up in the link below. If there are enough people sign up, I probably will just create this app as well. I hope you enjoyed this video. I'll continue post interesting AI applications that I explore. You can like and subscribe. Thank you, and I see you next time.